Hi everybody, this is our last lesson of Unit 1 and the last lesson that I'll be recording for all of you. I am going to continue recording lessons for the students that we have that are continuing to learn online, but the rest of you that are coming back on the 9th will get to have these lessons in person. Yay for that. All right, so our lesson for today is on finding the zeros of a polynomial. Do you remember that every polynomial has a degree? For example, this polynomial that I have written here is a degree 6 polynomial. And so a degree 6 polynomial has 6 zeros, or 6 solutions. 6 roots, sometimes they call them. Some of them are visible. If they're real zeros, or what we call rational zeros, then you can actually see them when you make the graph of the polynomial on a coordinate plane. So that's how we're going to start off, by finding the zeros graphically. So our step number 1 is going to be to graph this polynomial in some sort of graphing technology, because graphing it by hand would be a pain. So if you've got Desmos, you can use that. If you've got a graphing calculator, even better. I would suggest that this year for pre-calculus you get a graphing calculator. So I'm going to go to Desmos, and I've already graphed this for us on Desmos. And you can see on Desmos that the graph has a nice W shape, which makes sense because it was a 6th degree polynomial. Its end behavior, because of its positive leading coefficient, is both branches up. And we can see that it actually crosses the x-axis in 4 places. So I'm going to make a note of those 4 places, and I'm going to write them down back on my OneNote screen because I know 4 of the zeros already, just from looking at the graph. So back on my OneNote screen, I'm going to write down the 4 zeros that I saw. And the 4 zeros that I saw were at -1, +1/2, +1, and +3 as I moved across the graph. So those are 4 of them, but I'm still missing 2 more. And so to get those last 2, I'm going to have to take the ones that I found graphically, divide them out, which is like factoring them out, and then see what's left of the polynomial. I'll probably have to use the quadratic equation for that, because those are probably imaginary zeros, and I won't be able to find them by factoring or anything like that. All right, so let's use synthetic division to divide these out. If it really is a zero, -1/2 or -1, then when I divide it into the polynomial, I should get 0 at the end. Now when you set up your synthetic division, make sure that you leave zeros for any missing powers of x. And I see we've got 6, 5, 4, but we are missing x to the third in this polynomial. So I'm going to put a 0 there, and then -2, 7, and -3. So like I said, if -1 really is a 0, which is what I saw in the graph, then I should get 0 when I divide it into the polynomial. All right, so I bring down the first number for synthetic division, and then I begin the multiplying process, putting the number in the next column, and then adding the numbers in the column. So -1 times 2 is -2. Add those up and get -9. -1 times -9 is +9. Add that up and get 12. -1 times 12 is -12. Add that and get -12. -1 times -12 is +12. Add that up and get 10. -1 times 10 is -10. Add those up and get -3. -1 times -3 is 3. And sure enough, I get 0. So check. -1 is definitely a 0. Now, I don't have to go back to the original polynomial. I can use the coefficients that I have left of the remaining polynomial after dividing out the -1, which stands for really x plus 1. That's the first factor I've divided out. So now I can take 1/2 and I can do the same thing. And again, I should get 0 when I divide this. All right, so bring down the first number. Half of 2 is 1. That gives me -8. Half of -8 is -4. That gives me 8. Half of 8 is 4. That gives me -8. Half of -8 is -4. That gives me 6. Half of 6 is 3. Sure enough, I get 0. So 1/2 checks out, which means that x minus 1/2 is also a factor, and 1/2 is a 0. Okay, I'm going to move up a little bit here. The next one I'm going to divide in is 1. And again, I should get a 0. Here we go. 1 times 2 is 2. I get -6. 1 times -6 is -6. I add and get 2. 1 times 2. I'm going to go kind of fast here. What did I do? I didn't get a 0. 1 times 2, 2, -6, -6, 2, 2, oops, I didn't add right. How about that? Negative 6, there we go. I need you guys to help me to get these right. All right, so now I know that x minus 1 is a factor. And the last one that I need to do is 3. Oops, let's put 3 in the box right there. All right, here we go. See if we get a 0 for this one. 3 times 2 is 6. We get 0. 3 times 0 is 0. We get 2. Voila. Okay, they all checked out. All of the zeros that we saw in the graph checked out to be zeros by synthetic division. Now, this is what I was really trying to get at right here. Those numbers are what's left. They're the factorization final piece. And so the final piece of the factorization is 2x squared plus 0x plus 2. And so I see that I have another factor that needs to be broken down to find the last zeros. I've got 2x squared plus 2. So 2x squared plus 2 equals 0. That is factorable in the sense of taking out a GCF, but I can't do it any more than that. So it's not going to factor the traditional way. I could do the quadratic formula with a being 2 and b being 2, or a being 1 and b being, not b, c. Or I could just move everything over. Let's try that. 2x squared equals negative 2. Divide by 2. Get x squared equals negative 1. And then take the square root of both sides. Ooh, there's our I. 2 more zeros. This time we get imaginary solutions, I and negative I. So going back up to the top, this 6-degree polynomial does have 6 real zeros. And the 6 real zeros are the 4 that we saw in the graph, plus the 2 imaginaries that we got through a long process here of synthetic division to factor the polynomial. Okay, I've got 3 more examples for practice. They're not all going to work out exactly the same, so stay with me. All right, this one's only a 4th-degree polynomial, so we should expect 4 zeros, so that makes it shorter right off the bat. So let's go to Desmos and see if we've got any real zeros. Here's the second one. Wow, look at that. I see one at negative 6. I see one at negative 1. Ooh, that one looks like a fraction. If you recognize that decimal, it looks like 2/3, and that one looks like 1. So let's start with negative 6, negative 1, and 1, and see what we get. Negative 6, negative 1, and 1. Let's confirm those using synthetic division. Let me make sure that we're not missing anything here. We're not missing any powers of x, so we don't need to put any zeros into this synthetic division procedure. Let's go and confirm that this is a 0. 12, negative 3, 18, 2, negative 12. All right, that one checks out. So negative 6 is definitely a 0. Now let's take negative 1. We get 3. We get negative 3. We get negative 5, 5, 2, negative 2, 0. Check. And then 1. Our last one here. Okay, so what we're left with is 3x minus 2 equals 0. And sure enough, that does give us the 2/3, the fraction that we saw there. So our final 0 is 2/3, making the 4 zeros for this one all real, and they were all visible in the graph. I was just a little bit concerned about this one because it was not a nice value, but 2/3 is a pretty decent rational 0, so we confirmed it using synthetic division. Okay. All right, next one. This one is a 5th-degree polynomial, so it should have 5 zeros. Let's check the graph to see how many of them are real. Ooh, all right, we've got one at negative 2. That one's clear. And then what happens when a graph doesn't actually intersect, or it doesn't actually go through the x-axis, it just touches there? If you remember, that's what we call a double zero. Because it bounces off the axis there, that means that x equals 1 is actually a 0 twice. So we've got -2, 1, and 1. Let's try that. -2, 1, and 1. Let's confirm those 3. We'll start with -2, 1, 1. Ooh, wait a second. There's a 0 there. There's no x to the 4th, so I need a 0. 1, 0, 1, 2, -12, and 8. There we go. All right, so I go -2. That gives me 4. That gives me 5. That gives me -10. That gives me -8. 16, 4, -8, 0. I like synthetic division. I don't know. It's pretty slick. It just works really well. Okay, next one we're going to do is 1. Confirming these using synthetic division and breaking the polynomial down to its completely factored form so that we can use the quadratic formula on what's left. Nope, +4. By the way, thanks to those of you that caught my mistake in last week's video, because I couldn't figure it out until after I'd already quit recording. And then I didn't want to go back and record the video again. All right, I'm going to try 1 again because it should be a double 0. I keep putting that in the wrong spot. Let's go with 1 again here. It works. Okay, and what we're left with, remember, when you finally run out of real zeros, what you're left with is the coefficients of the remaining factor of the polynomial. So what we've proven so far is that this polynomial factors into x plus 2, x minus 1, another x minus 1, and then what we have here, highlighted in blue, x squared plus 0x plus 4. Okay, that's another quadratic that isn't factorable. So you can just go x squared plus 4 equals 0, move the 4 over, and get x equals plus or minus 2i. So we get 2i and -2i. So there they are. There are our 5 zeros because it's a 5th degree polynomial. You're going to get good at synthetic division and good at solving quadratics of different forms. The last one that I have for you, I think we're going to have to use the quadratic formula. All right, it's only a 4th degree polynomial, so we're expecting 4 zeros. We'll check the graph to see if any of them are real and visible on the graph. So here we go. The last one there. Come on. There it is. I only see -6 and +3. So 2 visible real solutions. We're going to go back, -6 and 3. We're going to verify those using synthetic division. 1, -3, -27, 135, and -162. I may need a calculator for this one. All right, here we go. We're going to get -9. We're going to get -6 times -9. We're going to get +54. We're going to add those two together. That's going to be 27. -6 times 27. Let's see. I don't have my calculator with me, guys. Can you believe it? 7 times 6 is 2. Carry the 4. 6 times 2 is 12. Did I do that right? 6 times 7 is 2. Carry the 4. 6 times 2 is 12. -162. So 62 to 52, 52 to 42. So I get -27. And then -6 times -27 is +162. All right. Whew, I would like to have a calculator for that. But it's okay. It worked out. All right, let's try 3 now. See if this gives us a shorter, easier solution. I get -6 there. I get -18. That gives me 9. That gives me 27. 0. Check. Okay, so what I have left is x squared minus 6x plus 9 equals 0. That looks factorable. Minus 3 and minus 3. Really? X minus 3 and x minus 3 equals 0. Aha! I didn't anticipate that. This is a triple 0. X equals 3 is a 0 3 times in this polynomial. And so a triple 0 is an intersection. It does go through the x-axis, and you just can't tell that it's a triple. There's no way to tell that by looking at it, whether it's a single 0 or a triple 0. The doubles give you that bounce off the axis, but not the triples or higher. All right, so we didn't have to use the quadratic formula. If you did, it is possible to get an answer where you would have something like x equals 2 plus or minus I square root of 3 over 10 or something weird like that. That is possible. You can get imaginary zeros like this. You would get that from doing the quadratic formula on a non-factorable quadratic. Okay, so for your homework on the worksheet, there's only about 4 or 5 of these for you to do, and then the rest is review. And then the second assignment for this week is a complete study guide that looks just like the test that you're going to have next week when you come back to school. So you've got lots of review this week. Please come to office hours if you can, so that I can go over these problems with you, or any problems from any of the 8 worksheets that we've done in this unit. It's going to be a big test, and you'll see what it looks like when you see the study guide. All right, see you guys soon. Bye.